we have the power set with the symbol B bracket open, A bracket close. So this is the symbol, and it also have a formula which is equals to 2n, where n is equals to number of sets. Let's say for P of A, just like this one, if you want to check the power set of the A subset, it's going to be, now we say n is what number of sets, and number of sets we have, number of the members we have here, number of elements we have here is 1 2 3 4 5. You have 5 numbers, so it's going to be 2n, whereas n is equals what, 5. It's going to be 2 times 2 times 2 times 2, 1 2 3 4 5. 2 times 2 is 4, 4 times 2 is 8, 16, 32. Then to check power set of B, you count it 1 2 3 4 5. So it's same as power set of A. So I will say the power set of B is equal to the power set of A, and power set of C is equal to 1 2 3 4 5 6. So we have 2 power 6, which is 2 times 2 times 2 times 2 times 2, 1 2 3 4 5 6. So we say 32, because 2 into 5 places here gives 32. Then multiply by these 2, we have 64. So this is the power set. Then you can also do the same for D. D is 8. So it's going to be 2 power 8. Then you can get to power set for that. So the next one we are going to, our next type of set is singleton set. Singleton set. Now a set with one element or member. Elements is same as members. All these are elements. All these are elements. This one, A, B, C, D, here are the subsets. Why all these down are elements? Their children are elements. So they are called elements or members. So I think I should change this number of elements in a set. Let me say number of elements in a subset. So for example, we can have P equals 3, or we say A is equals, and we have 6, or B, then we have 2 as the element. This one we have 6 as the element, and this one we have -3 as the only element. So this is how singleton set looks like. Now let's solve some problem on singleton set. Imagine you are asked to solve this problem. P is equal to x such that x plus 5 is equals to, we should find x. Now P is equals this, and they say we should find x. So x here, we are going to work with this. So x plus 5 is equals what, 2. right? Yeah. Then to make x subject of formula, to make x subject of formula, our x will be equal to 2 minus 5, because the 5 have to cross over to this, over this you have to cross over to the other side to meet these two, and then it turn to negative sign because it's positive. Now is here, our x is going to be equal to minus 3. For those who are going to be confused on how I got minus 3, you can solve it this way. Like, you are owing someone 5 naira, and this 2 here means that you, plus 2 here means that you have 2 naira with you. Once you go to clear off your debt, you will notice that you have 3 naira left. So that 3 naira left you are owing the person is this minus 3. So you pay your debt while 2 naira and 3 naira is remaining. So the remainder is this. So that is how I got my minus 3. Um, Number 7, we have the empty set. A set without any member. A set without any member is called an empty set. So to have a symbol is either like this, where there is no number or letter in between the brackets, or a circle and a dash. So let's go to the next one. The next one is called, that is number 8. It's called finite and infinite set. A finite set is countable, while infinite set is uncountable, cannot be counted. Now let's see this how finite and infinite look like. We have 1, 2, 3, and so on, like till 10. So this is a number from 1, 2, 3 to 10. So it's countable, is infinite. For B, we have 1, 2, 3, and the dash continues without any number down here, means it's infinite. Number 9, we have difference of two sets. Let's say A is equals A, C, K, M, and N. Should I use W? Okay, W, okay, I close the bracket, and B is equals P, arrow, M, A, and U. Okay, let me define it for you. Now, let me say member of element. Okay, sorry. Member or element of A that is not in B. That's the difference. That's definition for difference between two sets. Members of this that is not in this, and is this is a symbol. This is a symbol. Members of A that is not in B. Members of A that is not in B. And what are those members that are in A that is not in B? Now, if we want to check it, there's A here and there's A here. There's C here and there's no C here. So C is 1, K is here and there's no K here. K is 2, M is here, there's M here, N is here and there's no N here. N 3, W is here and there's no W here. So we have 4. So the difference is here, difference between two sets. So the difference between A to B is C, K, N, W. Understand? Remember that is in A, that is not in B. This is the answer. Now, let's go to the next one. Next one is called, that is number 10. Complement of a set. This is usually done between the universal and the subset. Normally done between the universal and the subset. So let's say element in the universal set that is not in the subset. So it's between the universal and the subset. Why for the difference between two sets is between the two subsets, and they are going to indicate it. Understand? They might say B to A for the difference between two subsets. So if it's B to A, let's say for instance, let me leave this one aside first. Let's do this one. If it's B, difference between B to A is going to be, okay, there's P here and there's no P here, so we're going to be P, and there's arrow here and there's no arrow here. It's going to be arrow. There's M here, there's A here, there's U and there's no U here. So it's going to be P arrow U. So that's the difference between B to A is P arrow U, and the difference between A to B is C K N W. Understand? So that's the difference between two sets. Between two subsets, yeah. But for complement of sets, it's normally done between the universal and the subset. So let's say we have a universal 1, 3, 6, 8, and 9, for instance, and A, which is a subset of the universal, is 3, 8, and then 9. Then remember the symbol for complement is A prime, or you say A power C, A1 or A power C. This is A prime. So let's say A prime be equal to, now let's do it. There's 1 here and there's no 1 here. It's going to be 1. There's 3 here and there's 3 here. There's 6 here and there's no 6 here. 6. There's 8 here and there's 8 here. There's 9 and there's 9 here. So the complement is 1 and 6. That's the complement. That's for the number 10 and number 11. We have cardinality of set. Cardinality of set looks like power set, but to have a little difference between them. It means number of elements contained in A. For instance, number of elements contained in A. Number of elements contained in A is 1, 2, 3, 4, 5. So we have 5 cardinality. If it's B, we have 1, 2, 3, 4, 5. So we have 5 cardinality. If it's C, 1, 2, 3, 4, 5, 6. We have 6 cardinality. For D, we have 8 cardinality. So that is how cardinality is being calculated. So that is simple. N brackets open, A, then brackets close. So this is how this symbol looks like. So if it's B, this A will change to B. If it's for cardinality of C, this A will change to C. If it's cardinality of D, this A will change to D. Yeah. So let's say, for example, A is equals UVW, and we're asked to find N of A. Then, if we count it, we have 1, 2, 3. Therefore, N is equals to what? 3. N of A is equals 3. So we have 3 cardinalities for N of A. Now, our next one we are going to go into now is the basic operation of sets. Basic operation of sets, that's what we are going to deal on now. So let's say basic operation of a set. Basic operation of set is just like minus, multiplication, addition, subtraction. Understand? So when working with sets, we have two basic operations: union of sets, and we have the intersection of sets. Now let's talk about the union of sets. Union of sets. Union of sets have a symbol U. Okay, let's say A union B. Therefore, we say it is the combination of elements of set A and B without repetition. Without repetition. So let's say, for instance, we have let me do some work example. Okay, let me do some work example in the next page. This side is filled up. Let's say we have example, we have A is equal to, let me say, 2, 6, 7, 9, 11, and 8. And our B is equal like 3, 6, 8, 9, and 10. Now, our A union B will be equal to 2, there's 2 here, 3, there's 3 here, 6 is 2, so we have to pick 1, and then 7 is here, and then 7 is just 1. We have 8, there's 8 here, and there's 8 here, so we have to pick 1, and 9, and 10, and 11. So combination of A and B without repetition. Are you getting me? Without repetition. So if the numbers are appeared like 2, like 9 appeared 2, 8 appeared 2, 6 appeared 2, you have to just pick only one without repetition. You have to pick one. Now the next one we are going to is the intersection of sets, and it have a symbol n. It's not like the n for the cardinality. Yeah. So if I say n for cardinality will be like a small n, while this other one for intersection will be like a big N, but not the capital letter N. So that's for that. So if you are asked to find the intersection of A and B, we say is the element that is found in A and also in B. So that is, we mean common elements. So we mean common elements. Now, what are those common elements? If we check this, the common elements here, 6 is here and 6 is here. So we say A intersect B is equal to 6. Which other one appear 2 times? Here and here. 8 and which other one? 9. So 9 are common between the both subsets. So that is intersection. That's what intersection is talking about. Then if they are not common, if they don't have any element in common, it's called disjoint. So that disjoint is opposite of intersection, is called disjoint. So let's say disjoint kind of set is when the subsets don't have common elements. When the subset don't have common elements, that is called disjoint. Understand? So that's for that. Like for instance, we have let's say A is equals like, let me say A, B, and C, and then B is equals, let's say D, E, and F. Therefore, A and B are what? Disjoint. They are disjoint kind of set. So if you love this video, I would like you to share it to your friends. They need it more. And if you are new to my channel, please subscribe. And if you have any question, you can comment on. Check on the description. You get a link there to watch the part 2 of this video. I'm going to talk more about the Venn diagram and also do some work examples on basic operations of sets and also the types of sets. So all are going to be under the part 2 of this video. So check it down on the description. All right, thank you very much for watching this video.